This video will explore the subject of anti-gravity, but in a less sci-fi term. Specifically, we are going to address the possibility of controlling non-magnetic objects using proton vibration energy, and I'll explain what that means as we continue along. But before moving on, please note that this presentation is in support of a new paper that I've posted on ResearchGate, which has all the details, including the math for those that want to explore the equations and derivations. The link can be found in the video description. First, we will be talking about non-magnetic objects. Why? It's already been shown that we can control magnetic objects and even levitate them. So we'll tackle other types of objects, such as this tennis ball. How would we control it and make it levitate if it is not magnetic? That's the concept of anti-gravity. Before moving forward, let's revisit gravity itself. For the past century, it's been defined by Einstein as a curvature of space-time. More recently, since the creation of the Standard Model, it is assumed that the force of gravity is mediated by a hypothetical graviton particle, which remains to be found. In this presentation, however, we are going to focus on a theory that connects gravity and electromagnetism. Now remember that the electric force and the magnetic force have already been combined in physics, and now we hope to merge gravity into that model too. Yes, it sounds like sci-fi, but the study of physics and the dream of uniting gravity with other forces could unlock our potential to manipulate gravity, and if we can, it will lead to innovative applications. The paper mentioned at the beginning of this video dives deep into experiments that have been conducted that have shown minor weight loss. Right? So not exactly anti-gravity, but it's a step forward. Now, the problem with some of these experiments is that they're hard to produce, and the weight loss is often less than a percentage of the body mass, not statistically significant to prove anti-gravity. On this page are two of the experiments that grabbed headlines in the 1990s and early 2000s. Yet there's something about these experiments and a couple of others that you'll find in the paper that are common when weight loss is found, and we'll come back to that in a moment. This paper proposes a new model and an equation to control any type of object, magnetic or non-magnetic, anything with mass. It's important to note that the mathematics in the paper are based on classical Newtonian physics, not based on quantum mechanics. Next, it uses equations from the electric force when computing gravity, something that might not be traditional for calculating gravity. The approach is perhaps out of the box, but then again, perhaps that's what we need right now if we are going to make a breakthrough and unite gravity with the electromagnetic force and build practical applications like anti-gravity. And so here it is, the equation that is proposed in the aforementioned paper to control motion, such as directing a force that counteracts Earth's gravity. It's important to note that it takes energy to do so, in this case electrical energy. It uses the conservation of energy law, so nothing is free. In fact, it requires a significant amount of energy just to show weight loss in an object. The equation was tested against existing experiments that have shown a slight reduction in weight loss, but failed to explain how or accurately model the weight loss based on their experiment parameters. Now, it was fairly accurate against validating experiments conducted by Eugene Podkletnov, and the results can be found in the paper. It was also fairly accurate to model experiments conducted by Martin Tajmar, and again, also found in the paper. And finally, although it could not be used to validate other experiments such as Boyd's experiment or Chukrkov's experiment because I lacked the data about their setups, but these experiments are highlighted in the paper because of the similarity in the device setup with others that have shown weight loss. The paper concludes with a schematic of a motion control prototype. There are similarities here with previous experiments, yes, but critically, understanding the how it works and specifically tuning to resonant frequencies, possibly why it's difficult to reproduce. But this proposed prototype, along with the equation for these frequencies and the anti-gravitational force, if you will, that it yields, could produce possibly a more statistically significant weight loss percentage than the previous experiments. Now, why should we do this? Even if we fail, we've learned something. And if we succeed, it can revolutionize life on Earth, where we experience gravity, but might want to minimize it for things like transportation. Or revolutionize life outside of Earth, in space, for example, to control gravity to create that artificial conditions to match what our bodies are accustomed to on Earth. There's lots of possibilities. Now, for future work, it will be exciting to see further research and experiments that show the direct link between the gravitational force and electromagnetism. That's the how it explains these experiments. And the work specific to the proposed model in this video, that likely next step is a computer simulation. And I hope to announce the OpenWave project in a future video. Lastly, the real proof will be a real-world experiment. Now, this likely requires a very high voltage lab to conduct this experiment. So I suspect that the likely stepping stone to get there will be the aforementioned computer simulation. And that's it, controlling non-magnetic objects using proton vibration energy.